So when you have polynomials, we did the long division in day 1 of 1-2. It's not usually the most favorite way of doing it, but it is the way that'll work every time as long as you do it right. Synthetic does have its limitations, and sometimes synthetic can actually be really, really difficult. It really boils down to what particular binomial you're trying to divide out of there. This has basically a 1 right here on that leading coefficient. When there's a 1 there, it's actually quite a bit easier. If there's another number there, you have to do a whole lot of work to get this thing set up so that you can even try synthetic. And then normally there's lots of fractions involved. Okay? So normally people stay away from it at that point and just do the long division. But when there is a 1 out there, synthetic works really slick. And does anybody remember the general setup for synthetic? Like, how do you start it? Anybody remember? Yeah. Okay. I was told to put a -3 kind of in that little box off to the side like that. That's just to set it aside. Now, how do you decide what number you put in there? How is that decided, technically? Okay. A lot of the ways that it's learned is because if there is a 1 here, it's really slick that it works that it's just the opposite of that value right there. But hopefully you can see with me that x plus 3 would possibly be a factor, right? And what's the 0 that goes with that? Well, to find out what zeros are, you set it equal to 0, right? And then you solve. When you solve, what x value results is -3. And that's really why the -3 goes in that blank there, because you're trying to see, is that actually one of the zeros? Does -3 make this work or not? Okay, so that's a good start. Okay, what do we do next? Because really, there's not much more. What are we going to do? There's a box with a -3 in it. You know, what are you going to do after that? Yeah. Okay, so 2 here. Very good. 0. Why the 0? Yeah, because here's x to the 4th, right? 2x to the 4th. There is no x to the 3rd, so you do have to put the 0 there. And you have to make sure it's descending order. So 4th, 3rd's missing. Here's 2nd, so -9. And then here's to the 1st power. So, well, you don't normally write the plus, I suppose. So we'll just put 17 there, and then we'll put a 3 here. Okay, I'm just going to get this work off to the side so I don't get it confused. Okay, so that's a really good start. There's just a little bit more in the setup, and then we can get going. Yes, draw a line just anywhere I want. Just draw a line. Any type of line. Oh, horizontal line. There we go. Okay, you could drop down too, but one thing I like to do is I go between these last 2 numbers here, in between these last 2, and I work down here, and I put like a little squiggle down there like that. The reason I put a little squiggle is because if you just put a line, it could look like a 1. Right? So I put a squiggle, so that's going to kind of tell me where the remainder is in this problem. But it is best to put it between those last 2 terms. Now keep in mind, if this constant term right there was missing, you would actually have to put a 0 at the end of this. Okay, and you still would put it between the last 2. And now before you told me to put the line in, somebody said, well, you drop down the 2. Yeah, pretty much you take whatever this first coefficient is right here, and you just drop it, and you put it right down there. Okay. And really, if we were to do the long division for this off to the side, we would see virtually the same number showing up in the long division. It's just this is a nice, neat way of organizing it. Okay? And so now what we got to do is we got to find out how close we got, right? So basically you take, called the splash effect normally, from one student a long time ago that remembered it that way, and it worked. They said, did you go like this? It goes, and it splashes up into there. I don't know, it worked for them. All right, and so it has worked for other groups in the past. So you take -3 times 2, because you got to find out, well, how close did I get? -3 times 2 is -6, right? And then here's the biggest difference between this and long division. In long division, you have to always make sure that you change the signs. Okay? In synthetic, you don't have to, because you could, in a way, you could almost look at it as that you already have changed all the signs for yourself. Okay, you could look at it that way. So it's just 0 I have here, and then a -6. Well, if I had a 0 and a -6, the end result is a -6 if I combine them. And then the splash effect again. And of course, sound effects are optional when you do it. So -3 times -6 is +18. Do I change the sign? No, we already took care of that. So now I just have to take the -9 and the +18 and combine them, and what is the end result? +9. Now what? Okay, so splash effect, right? So what is that, negative 27? Change the sign? Nope. Just combine them, and what do we get if we combine them? Negative 10. Splash effect. So you take the negative 3 times the negative 10 that's down here, and we get a positive 30. Wow, that's a terrible 3, but there you go. You add it together, and 33 is the remainder. So for negative 3 to have been the 0, I would have had a remainder of 0. So in other words, is, not that I have to, but really we have divided it out. But really we know right now that x plus 3 is not one of the factors, because it did not divide out evenly. There was a remainder. Okay, it didn't come out of there perfectly. Now, of course, so this is a nice shortcut, but a lot of times you need kind of the variable back in there to help you out in the end, right? The variable is very helpful. There's two ways you can kind of throw the variable back in. We know that we started with x to the 4th. And we basically tried to take just x out, correct? In fact, we did. We took that x out. We actually took out x plus 3. So in other words, there were 4 of them. I took one of them out, so there should be 3 remaining, correct? 3 of the pieces. And so then this must be x to the 3rd, and then you just go descending order. So really, if I divide it out, it would look something like this. Your answer would be plus 9x minus 10, and then you could put plus 33 over x plus 3, because you really are still trying to divide by the x plus 3. Or you could just put remainder 33. Now you notice down here for part B, I've given you basically the same problem, except I've asked you just to find out what is t of negative 3. So in other words, substitute negative 3 in for all the x values. So why don't you take a second and I'll kind of get it set up for you, and then maybe we'll just run through this one together. And hopefully later in this chapter we can really solidify the significance of these two parts, A and B here. So t of negative 3 basically means any place you see that x, put in negative 3. And notice again I put the parentheses like we learned the other day. How come I didn't worry about the missing term this time? Okay, so I don't have to worry about the x of the 3rd term? How come?
0.
Yeah, I would take 0 times that anyway, so it'd still be 0, right? Even if I tried to sneak that in there for the 0, it doesn't matter. It's 0 times that anyways. All right, so what are we looking at here? We got to figure out what's going on. So we got to do the order of operations, of course. So we have 2 times negative 3 to the 4th. You have to do negative 3 to the 4th first. So in other words, it's a negative times a negative times a negative times a negative. That ends up positive. How about 3 to the 4th? Does anybody happen to know that one? What is it? 81, very good. So this portion of it's 81, which then I take times 2 is 162. Okay. Now in this next one, you have to be very careful, because you can run into problems. Some take the negative that's out front here times the negative on the inside, and you shouldn't do that first. You should actually go ahead and take it to the 2nd power first. So take negative 3 to the 2nd power, we end up with a positive 9, which I take times a negative 9 out front, and I get negative 81. And then this negative 3 that's over here does not have a power to it, so I don't have to worry about that one as much. 17 times 3 is 51, but it would be negative, right? And then plus 3. So not very surprisingly to me, t of negative 3 is 33. Have we seen that number somewhere? Yes. I sure hope so. If not, we did one of the others wrong. Yeah.
Wait, what's negative?
81 is negative 3 to the 4th power. Yep. So it should be 33. So you see there is a pretty quick way to find out what the remainder would be, but notice what got put into the function was the 0, right? So it was the negative 3 like we put into the synthetic. Okay. So that's a quick way to find out if it's going to work real well, but does it give you what was left over once you did it? No, it didn't. So you see what there is benefits to each of them. This one down here is really quick, part B, but it doesn't give you what was left over. So then you'd have to possibly go do it anyways. Okay, so do you see how there could be a potential advantage to one way or the other? Okay. Any questions so far on synthetic? Very similar to long division, it's just normally preferred because all the x's are gone while you're doing your work. If you haven't done so already, why don't you go ahead and try and determine if x plus 4, it is x plus 4 this time, is a factor of that. And I believe it might be the same one from yesterday, is it? I don't even know. It might be. So take a shot at that and see what you get, and also try letter B down at the bottom. I'll come around, see how you're doing. All right, let's see how you did. It seemed like most of you had the same answer, but it seemed like a few of you were maybe a little different. All right, so we've got x minus 4. We don't know if that's the factor. We could use long division, right, and try and find out. Or we could go with synthetic, because this is a setup that's really good for synthetic with that 1 kind of as that leading coefficient. All right, so in here you have to put what? What will go in the box? Yeah, negative 4. And then we go what? 1, 3, negative 1, 11, negative 4. Are you in agreement? Again, here's your last two terms, the 11 and the negative 4. So down here, just put a little squiggle in there. So we drop down the first term, which is 1. Then here would go negative 4 times 1 is negative 4. Negative 1, very good. And then we take negative 4 times that, which is 4. 3. Negative 12, which is negative 1. And then 4, which means 0. So at this point, can you answer the question? Yeah, you can answer the question quite easily. Is x plus 4 a factor? Yes, because it divided out perfectly. The remainder is 0. So really the answer to the question, yes. But let's just make sure that we know what was left over. It really was x to the 4th to begin with. I took one of them out, so this would be x to the 3rd, x squared plus 3x minus 1. So if I were to take this x to the 3rd minus x squared plus 3x minus 1, and I were to take it times x plus 4 and multiply it all out, what would I get? Yeah, the x to the 4th plus 3x to the 3rd minus x squared plus 11x minus 4. That's kind of how division, right? All multiplication and division are the opposites of each other, so that would work out perfectly. It would come out to that. Okay. So if I did this bottom part right, what should f of negative 4 be, seeing they are the exact same function as what we had up above? It should come out to be 0. Well, let's find out. That means I got to put negative 4 in. There we go. All right, does anybody happen to know negative 4 to the 4th? Very good, 256. Positive or negative? Positive, okay, 256, positive. Now on this one you would do negative 4 to the 3rd. Anybody know that one? Oh, not yet. That's if you times it out at the 3, yeah. Yeah. So negative 4 to the 3rd is a negative, agreed? 64, very good. And then I take it times 3 is a negative. Well, there we go, 192. All right. So now on this one, be careful how you deal with negatives. You take the negative 4 and square, that's a positive 16, correct? Which turns into a negative 16 once you take it times the negative that's kind of out front. And then minus 44 minus 4. And it is equal to 0. Yes. Okay. Yep. The caret key is the key, but you have to be careful, especially if you do something like negative 4 caret 3rd power. If you type it in just like that, it takes 4 to the 3rd power and slaps a negative on it. Okay? Or in that case, it wouldn't actually be wrong, but the one that you probably got in trouble with was maybe that one. Put negative 4 in parentheses and then caret 4. Then it takes all of it to the 4th power. Yep. Yep. Mm-hmm. Yeah, and you can do it that way too. The question is on the calculators, how does that work out? If you want to take negative 4 and take it to the 4th, you'd have to put it in parentheses. Or you can kind of figure out what the answer would be in the end and just take 4 to the 4th and then just make it positive or negative yourself by knowing what it would be. Mm-hmm. Definitely. All right. And on the back of your sheet, you can add another example. And the example is given and I'll let you write that down. Yep, that's a K. Yep. What you have to do is determine K such that the remainder will be 13. And again, I could pick any remainder at this point, but I picked one. I just did the problem over here quick that hopefully works out. Yes. I'm not asking you for a factor. Nope. No, let me see. Maybe I just messed up and we'll just have to delete this part. Oh, yeah. We'll say, what should we do? Let's see here. No, I think we'll go with 1. I think just 1, yeah. Well, the factor would be x minus 1, I think, yeah. So here's what we would do. What would we put? Yeah, I'm not sure this is going to work out the way I want it to. And if not, we'll just hit the delete key and I'll make up another one. Okay. What determine K so that the remainder will be 13. Put 1 in. Yeah, again, this might not work. I just made this up on the cuff, off the cuff here. So you put 1 in here, right? Everybody with me so far? So how do I finish this up? I put what here? 1 and 2 and K and 7 and squiggle. We want the remainder to be 13, correct? How do you start? Yeah, there's lots of ways you can start, but you kind of have to work forward and backwards, right? To get to where you need to be. You have to get to where K is. So what's probably the best way? I would probably just bring down the 1. And then what's the next thing I could figure out? 1 times 1 is 1. And then I can figure out 3. And then I can figure out 3. But then you get stuck, right? Well, I don't know what the bottom's got to be. If I knew what the bottom had to be, I could figure out what K was. Well, we need 7 and then something in this slot that'll give me 13 in the end. So what's got to go in that oval area? There? Yeah, 6. Okay, that's the only thing that'll work there, right? So now what you have to do is figure out we've got 1 times what would give me 6. We agree with 6? So is that 6 that I just wrote down there, is that the answer for K? Oh, but sometimes you want to write that, right? Because you wrote it, oh, that's what it's got to be. But now what you have to do is, okay, now I know I basically have K plus a 3 has to end up equaling 6 is really what we have to solve now, right? And K then has to be 3. Okay. Okay. Any questions? Keep in mind that K does not have to be an integer. Any questions?